So we have today's class moments. Definition: the nth moment about origin of a random variable x is defined as the expected value of the nth power of x. The moment about origin. Raw moments. For discrete mu n dash is equal to e of x power n into summation of I into xi power n into p of xi, where n greater than or equal to 1. For continuous mu n dash e of x power n is equals to minus infinity to plus infinity x power n into f of x into dx for n greater than or equal to 1. Moment about origin. Next is the moment about mean, central moments. For discrete mu n is equal to e of x minus x bar whole power n, which is equal to summation of xi minus x bar whole power n into p of xi. For the continuous mu n is equals to e of x minus x bar whole power n into minus infinity to plus infinity x minus x bar whole power n into f of x into dx for n greater than or equal to 1. We have the next formula relationship between the moments about origin and the moment about mean. The formula first rth moment mu r is equal to mu r dash minus rc1 mu into mu r minus 1 dash plus rc2 mu square into mu r minus 2 dash. Here mu 1 equal to 0. First, if r equal to 0, mu 1 equal to 0, first moment. If r is equal to 2, mu 2 is equal to mu 2 dash minus mu 1 dash whole square. If r is equals to 3, mu 3 dash minus 3 into mu 2 dash mu 1 dash plus t 2 into mu 1 dash whole cube. If r is equals to 4, mu 4 equal to mu 4 dash minus 4 into mu 3 dash mu 1 dash plus 6 mu 2 dash into mu 1 dash whole square minus 3 into mu 1 dash whole power 4. So these four are the first four moments. The next heading is the moment generating function. The moment generating function of a random variable about the origin is defined for discrete mx of t is equals to e of e power tx is equal to summation of e power tx into p of x. For the continuous mx of t is equal to e of e power tx, which is equals to minus infinity to plus infinity e power tx into f of x into dx. And we have one more relation. Suppose if we needed the value of mu 1 which is nothing but the mx of t will be given the moment generating function. If we differentiate with respect to t and put t equal to 0, this is the value of mu 1 dash. If differentiate with respect to t twice, means d square by dt square and put t equal to 0, that is the value of mu 2 dash. In general, mu r dash is equal to t power r by dt power r into mx of t equal to 0. And some value will be given. This is the, after we solving the problem, the moment generating function will be right in the expression of 1 plus t into mu 1 dash by 1 factorial plus t square by 2 factorial into mu 2 dash plus etc t power r by r factorial into mu r dash. Here mu r dash, which is nothing but the coefficient of t power r by r factorial from the moment generating function mx of t. Suppose if we needed a mu 2 dash is nothing but the coefficient of t square by 2 factorial. If you want to find mu 1 dash, the coefficient of t by 1 factorial from the moment generating function mx of t. So these are the basics of the formula for the moment and the moment generating function. Now we have the problem for the moment generating function. So here, let's see the question. Find the first three moments of x if x has the distribution x values are minus 2, 1, 3 and p of x 1 by 2, 1 by 4, 1 by 4. So the question is find the first three moments, which means mu 1 dash, mu 2 dash, mu 3 dash are the first in three moments. Clearly the given is the data is the discrete random variable. So for the discrete random variable we have the formula already. Mu 1 n dash is equal to e of x power n is equal to summation of I into xi power n into p of xi. So that's the formula. Now If n is equal to 1 in this, mu 1 dash is equal to n is equal to 1, which is e of x, which is summation of I into xi power n into p of xi. So now, so for n is equal to 1, e of x, which is x into p of x. So multiply minus 2 into 1 by 2 plus 1 into 1 by 4 plus 3 into 1 by 4. After multiply, this is 2 after cancellation minus 1. This is plus 1 by 4 plus 3 by 4. The answer is 0. And n equal to 2. For n equal to 2, this is substitute mu 2 dash is equal to e of x square. E of x square is nothing but summation of xi square into p of xi. So xi square means this we have to squaring and multiply by p of x. So minus 2 whole square into 1 by 2. So it is 4 into 1 by 2 plus, because of the summation, plus 1 square into 1 by 4. So 1 into 1 by 4 plus 3 square. So 9 into 1 by 4. So after simplifying, mu 2 dash is equal to 9 by 2. For n is equals to 3, here it is mu 3 dash is equal to e of x cube is equals to summation of I into xi cube into p of xi. So we have to cubic of the given x values and multiply by p of x. So minus 2 cube into 1 by 2 minus 8 by 2 plus, because of the summation, plus 1 cube into 1 by 4, 1 into 1 by 4 plus 3 cube, which is 27 into 1 by 4 is equals to 3. So these three are the first three moments given for the given random, discrete random variable question. The next, the random variable x has the probability function f of x is equal to 1 by 2 power x, where x is equal to 1 by 3, 1, 2, 3, etc. Find the moment generating function and find mean. Here mx of t is equal to summation of x into e power tx into p of x. This is equal to summation of x is equal to 1 to infinity. We have the formula e power tx into p of x. So this is e power t of tx into p of x, it is given. Instead of p of x or f of x, it is 1 by 2 power x. So simply we can write sigma x is equal to 1 to infinity. Here also 1 power x is there. Here also 1 x is there. So we can write e power t by 2 whole power x. Now we have expansion of this. X is equal to 1 e power t by 2 whole power 1 plus, because of the summation is plus, x is equal to 2 e power t by 2 whole square plus x is equal to 3 e power t by 2 whole cube plus etc. etc. So in this series, take 1 e power t by 2 constant. So 1 plus e power t by 2 plus, already we have taken e power t by 2 common. So e power t by 2 whole square plus etc. etc. Now e power t by 2 into, we have the expansion of 1 plus x square. What is the formula? 1 plus x square. 1 minus x whole power minus 1. Here x is equal to e power t by 2. So 1 minus e power t by 2 whole power minus 1. Now this is the expansion. Now take the LCM of this. 2 minus e power t by 2 whole power minus 1. So as in any expansion a by b, in general a by b whole inverse is equal to b by a. So here 2 minus e power t by 2 whole inverse, which is 2 by 1 minus e power t whole inverse. So after the expansion and cancel the e power t, this is 2 minus e power t by 2 whole inverse. 2 minus e power t by 2 is equals to 2 by 1 minus e power t. So after cancellation of 2 e power t by 2 minus e power t. So this is moment generating function. The question is again find the mean. Mean is equal to, so we have the expansion of the a moment generating function. We have the formula also already, e of x, which is nothing but a differentiate with respect to t from the moment generating function and put t equal to 0. This is the moment generating function. We have to differentiate with respect to t and t equal to 0 from this moment generating function e power t by 2 minus e power t. So we have differentiation is with respect to t. So both the numerator and denominator t is there. So we use the formula u by v differentiation. We have a u by v differentiation is v into u dash minus u into v dash divided by v square. Here u is equals to e power t and v is equal to 2 minus e power t. So after the using the formula, this is v square where v is equal to 2 minus e power t. So 2 minus e power t whole square into v into u dash. So 2 minus e power t into u dash, u is equal to e power t. E power t differentiation also e power t minus e power t into v into uh, minus u into v dash. So here 2 minus e power t is the value of v. Now a differentiation of this minus e power t divided by v square 2 minus e power t whole square. Now put t equal to 0. Directly we can substitute e power 0, e power 0, e power 0 and e power 0, and here also e power 0. We have the e power 0 value is 1. So now 2 minus 1 is equal to 1. 1. Here e power 0 and e power 0 minus into minus plus. So 1 plus 1 2. Divided by 2 square is 4. So now e power here 2 minus 1 into here e power 0 1 minus into minus plus 1. So the expansion of simplifying all the answers, numerator and the denominator, and the answer. Now on the next question, find the moment generating function for the following function is given by x and p of x. Here x values are given 0 to 6 and p of x. The question is find mx of t because of the moment generating function. So the moment generating function formula summation of x is equal to x is equal to 0 to n e power tx into p of x. So now x is equal to the data are given 0 to 6. So x is equal to 0 to 6 into e power tx into p of x. First x is equal to 0 e power 0 into p of 0 plus x is equal to 1 e power t into p of 1 plus x is equal to 2 e power 2t into p of 2 plus etc. and up to x is equal to 6 e power 60 into p of 6. And e power 0 equal to 1 into p of 0. If x is equal to 0, p of 0 equal to 1 by 47. And plus e power here e power t into p of 1. For p of 1 is equal to 3 by 49. And substitute all the values. If anything is common, we can take it. Here 1 by 49 is the common for all p of x. So take the constant 1 by 49 and expand. We cannot able to express this. So this is the final answer. And in the next question, a random variable has the moment generating function mx of t is equals to 3 by 3 minus t. Obtain the standard deviation. So the question is the moment generating function already given. We have to find the standard deviation. Standard deviation is nothing but the square root of variance, where variance of x is equal to e of x square minus e of x the whole square. E of x square equal to mu 2 dash and e of x is equal to mu 1 dash. So e of x square minus e of x the whole square, which is nothing but mu 2 dash minus mu 1 dash whole square. So now first we can start mx of t. We should find the value of mu 1 dash. So and the mu 2 dash. Before that we can write the expression in this. So in the denominator take the common 3 into 1 minus t by 3. So after 3 cancelled, it is 1 minus t by 3 whole power minus 1. And this is the expansion of the formula 1 minus x whole power minus 1. 1 minus x whole power minus 1 is 1 plus x square plus x cube etc. etc. Now 1 plus t by this t by 3 we can write it as 1 by t by 1 t by 1 factorial into the remaining the constant is 1 by 3 plus instead of this t square by 3 square is 9. So we can write t square instead of t square by 9, which is t square by 2 factorial into the remaining 2 by 9, because 2 factorial is equal to 2 into 1 is equal to 2. 2 after cancellation it is t square by 9. This is the answer. And in this t cube by 27, first we write the expression in t cube by 3 factorial, and whatever the remaining constant it is 6 by 27. So now Here, first, this is the expression of mx of t. Now we have the formula mu r dash is equal to coefficient of t power r by r factorial, and mu 1 dash is equal to coefficient of t power 1 by 1 factorial. Mu 2 dash is equal to coefficient of t square by 2 factorial. Now t coefficient of t square by 2 factorial is equal to 2 by 9. Coefficient of t by 1 factorial is equal to 1 by 3. Now we can go for the variance because of the standard deviation in the question. Standard deviation is square root of variance, but variance is equal to mu 2 dash minus mu 1 dash whole square. So we have the answer. Mu 2 dash is equals to 2 by 9 minus mu 1 dash whole square. Mu 1 dash answer is 1 by 3 the whole square 1 by 9, which is equal to 2 by 9 minus 1 by 9 equal to 1 by 9. Therefore, standard deviation is equal to square root of variance. Square root of 1 by root 9 is equal to 1 by 3.